Okay, this is what we have to do for today's lab. This is a continuation of what we started in the last lab, and in this particular session what we are going to do is we are going to again look at the plot command, and we are going to improve our figures or plots using some properties of that plot. For example, whenever you create a plot, if you want to add a title to the plot, so you can add a title. Okay? If you want to label the x-axis, like what is going on, which quantity does the x-axis represent or show, and which quantity does the y-axis represent or show, so you can do that as well. Similarly, there are other attributes of the plot that you can change. You can change the color of the lines, you can change the line style, the width, or you can add markers to the data points that you are plotting. So first of all, we'll talk about these, and then we'll talk about subplot command. In the subplot command, what you can do is you can create multiple plots in just one figure. So you can have one figure, and that figure can contain multiple plots, multiple functions plotted in one figure. Okay, so how are we going to do that? So we are going to learn about that as well. So the first thing is we'll again use the plot command, and then we will use or modify some properties of the figures that we create using that plot command. So let's get started. Okay? So we can write our code on the command window, and we can also write our code using the editor. Okay? So let us create a script file, and let me store it as lab 11, and this is script 1, say. Okay, so what are we going to do here? So we are going to create a plot, and then we are going to change some characteristics of that plot. Okay? So we are going to change some characteristics using like the title of the plot, the label for the x-axis, the label for the y-axis, and then we are going to change some characteristics or attributes of the actual plot that we have. And the way we are going to do it, we are going to specify different attributes as combinations of names and values, like which attribute do we want to change, and what do we want to assign the value to that attribute. Okay, so we are going to modify the different attributes of a plot using these name value pairs. Okay, so we'll specify that we want to change this attribute, and this is the value that we want this attribute to have. Okay, so we are going to do that. Now let's first create a plot. So first of all, let us clear the workspace window, then the command window, and then let us create a plot. Okay? So for example, we want to plot this function. We have 4 functions here. One of the functions is cos of 4t. Okay, so let me create this function. So in order to create cos of 4t, I'll need t. T is the time. So first of all, let me create the vector t, and t is, say for example, let us create it using the linspace function, and in the linspace function you specify the lower and upper bounds for this variable. So I want t to start from 0, and I want t to go to say for example 2 seconds. Okay, and I want say 50 points in between. So this will create a vector of 50 points or 50 elements. The first element would be 0 and the last element would be 2, and this is our t vector. Okay? And now we want to create the function of this particular vector t, and that is cos of 4t. Okay? So let me call that function as f1. So f1 is equal to cos of 4 times t. Okay, so this is f1. This is the function that we want to plot. ठीक है, cos of 4t. Okay, so this is t is time, and it starts from 0, goes up until 2, and there are 50 elements between these two in this interval, in this closed interval. And this is our function f1, cos of 4t. Okay? Now we know how to do this. Like we have done it. We know how to plot it. So you specify the vector for the x-axis and the vector for the y-axis, and then we get a plot. Okay? So if you run this file, you'll get a plot. This plot. This is cos of 4t. This function is cos of 4t. Okay? Now we don't know like what kind of function is this. We don't know what is on the x-axis, what is on the y-axis. Okay? Like what does this value represent, what does this value represent, we don't know. So you can label the x-axis, you can label the y-axis, and you can add a title to this plot. How? So you can say title, and then you can specify a string as title. Okay? So this would become the title of this plot. So this is plot of cos, say for example, this is what we want to give 4t. This is the title that we want it to have. So this would become the title of this plot. Then we want to label the x-axis. So we say x label, and then we specify the label for the x-axis. So on the x-axis we have time, and the unit for time is seconds. Okay, so that is what we want to show on the x-axis. And then on the y-axis we have the cos of time. Okay, cos of 4t. That is what we have on the y-axis. So when you specify these attributes, then the next time when we run this code, so the plot or the figure will have an appropriate title, it will have an x label and a y label. Okay, so if you run this code, so you can see that here we have the title appears here, and on the x-axis we have time and seconds printed, the x label that we specified, and on the y-axis we can see cos of 4t. Okay, so you can specify what is on the x-axis or what data is plotted on the x-axis. Okay, what is the quantity that is plotted on the x-axis, along the x-axis, and which quantity is represented by the y-axis or is plotted along the y-axis. So you can do that. Okay, this is one thing. Second is, like if you notice this line is very thin. Okay, so if you want to change the thickness of this line, so we can change the thickness of this line. If you want to change the color of this line, we can do that as well. Okay, and if you want to show the points for which we have determined the value of cos, so we can show those points as well, because these are 50 points. Okay, and those 50 points have been joined together by straight lines. So we can highlight those points that this is the value of t for which we have determined the cos of 4t. This is another value of t. So all the values of t's for which we have determined the value of cos, so we can highlight or mark those points. Okay. So how can you do that? So for this we have this particular format. Like we can specify or change the different attributes of a plot using this combination name value. So you specify the attribute that you want to change using the name, and then you specify a value for that attribute. Okay? So for example, we want to change the line width. Okay? So you can change it like this. You can say plot t comma f1, and then you specify which attribute do you want to change. Okay? So we want to change the line width, say for example. So you specify that attribute. We want to change the line width, and you specify the attribute within single quotes. So this is the attribute that we want to change. This is the name of the attribute that we want to change. And then you specify a value for this attribute. Okay? You specify a value for this attribute. So I guess by default the line width is 0.5. I guess that is what its default value is. If we change it to 1, so let's see what becomes of it. Let us make it 5, say. So now like it is very visible, very thick. Okay, so this is 5. I guess by default it was 1. You can maybe reduce it slightly. Let us make it 3. So this is line width 3. Okay. So we change the width of the line or the thickness of the line using the attribute line width. So how do you change it? You first specify the attribute that you want to change, and then immediately you specify the value for that attribute. Say for example we want to change another attribute. We want to mark the data points. Okay? We want to mark the data points. So how can we do that? So for that we can choose a marker. For that we can choose a marker. By default no marker is chosen. By default no marker is chosen. Okay? So you can change that. Like you can mark a data point with a symbol that this is a data point. For this particular value of x and y we have like a data point. For this particular value of x we have calculated the value of y and we have plotted that value, and then we have joined these points using straight lines. So we can use a marker. So we can specify that we want to use a marker, and then we can choose a particular marker. Okay? So we have different options here. You can use the asterisk, the 0, yeah, O, plus, dot. We have these different types of options that we can choose as markers. Say for example we want to choose asterisk as the marker. Okay? So when we run this code, so now you can see all our data points marked using the asterisk marker. Okay? Since the line is very thick, so that's why it's not very clear that we can, like you cannot very clearly see this asterisk. Let us use another marker. Say we want to use O or 0 circles. Okay. Let me change the width back to 1. Okay? So now you can clearly see that this is the marker, circle marker or circular marker. This is another marker, the plus sign. Okay? Similarly, we can use the asterisk marker. So these are the points, these are the 50 points for which we have generated the value of t and the value of cos of 4t. And then these 50 points are joined using straight lines. These 50 points are joined using straight lines. ठीक है? If you reduce the number of points, for example 10, so here you'll clearly see that you have 10 points, ठीक है? For which you have like determined the value of t and determine the value of cos of 4t. So these are those 10 points, ठीक है? Okay, so we have other attributes as well. You can change the line style and you can change the color of the line as well. So say for example we want to change the color of the line, ठीक है? So for that we use the attribute color, ठीक है? And you can specify color using different values, using different methods. First is you can specify it using a character label. For example, we want red color, so you can say R, ठीक है? R for red. So you can specify the color as R for red, ठीक है? So now the plot will have, the line will have, the color of the line would be red, ठीक है? You can specify say green, ठीक है? You can specify blue. There are other combinations as well, ठीक है? There are other colors available as well, and for that you need to check out the online documentation of the plot function, and there are other attributes available as well, ठीक है? So you can change different attributes. For example, you can change the size of this marker. I don't remember the exact name of that attribute. I guess it is marker size or something. We can try it, ठीक है? So this is marker, and then we can try maybe marker size. I'm not sure about that, but say marker size, ठीक है? So let's see if this is an attribute or not. I guess it didn't make any effect, so this is not a valid attribute, but you can explore, okay? Similarly, you can change the line style. The line that joins these two, every two consecutive data points, you can change the style of that line, ठीक है? Line style. So this is the line that joins the two consecutive attributes. So you can change the style of this line. By default, it is this style, ठीक है? So we can change it to say, for example, something like dot and dash, ठीक है? Dot and dash, or dash and dot. So now you can see that the straight line that joins two consecutive points, its style has changed, okay? It is a broken line, so dot and dash, dot and dash. Maybe you cannot clearly see it here, but on your screens, if you try it, you'll notice it, ठीक है? Let me reduce the data points, so then it will be clearer. Okay, so let us try this one, just the dot. So the line would be drawn using dots, ठीक है? I guess this is not a valid line style. Let us choose this one. So if you choose this one, we can see a dotted line. Okay? Maybe it is clearer on your screens. It may not be clear here on the projector, maybe it is clearer on your screens, but the point is that you can change different attributes of a plot using this name value combination. You can specify the name of the attribute that you want to change, and then you can specify the value for that attribute. Okay? Similarly, you can specify the name of the attribute and the value for that attribute, and you can specify as many attributes as you want. You can change the values of as many attributes as you want in this particular way. Okay, so now when I increase the line width, then it becomes clearer. Okay? So what are we going to do? We are going to plot two different functions on the same figure. Okay? We are going to plot two different functions on the same figure, and they are going to be plotted on the same figure, like on the same plot. So we are not going to have different plots or different x's for those functions. We are going to have the same pair of x's, and on the same pair of x and y axis we are going to have these two functions. Okay? If you want to do that, there are multiple ways of doing it. So last time what we did was, we did something like this. We said plot, and then you specify x1, y1, this is the first function, then x2, y2, second function x3, y3, third function, so on and so forth. Okay? So this is what we did last time. This is one way of doing it. You can also do it this way. If you don't want to use like one plot command and specify all the functions in that same command, so you can have multiple calls to the plot function, and in order to do that you need to use this command. It is called hold on. Hold on means that when you plot this particular function, then hold on to this function while plotting this particular function. If you don't do hold on, then when you plot this function, the previous function would be erased. It would be overwritten. Okay, we'll see that. So first of all, we want to plot the cos function, cos 4t. Then we want to plot the sine function, sine 4t. Okay? So let us specify these different attributes. So let me specify a different marker for the sine function. Let it be a circle. Let me specify a different color for this function. Okay? So let it be red, cos in blue. Okay? And let us specify a different line style. So line style for this function would be the dot line style. Okay? Okay, so we are going to plot these two functions, cos of 4t, sine of 4t, and they would appear on the same pair of axes. Okay? And we are using hold on and hold off commands to ensure that. So let us run this code and see what do we have. So this is what we have. Okay? We have the sine function and the cosine function in two different colors, using different markers, using different line styles. Okay? So we have these two functions and they are plotted on the same pair of axes. This is one way of doing it. Okay? The other way can be like, we can have one plot or one pair of axes for cos, the other for sine, then for some other function and some other function. So we can do that as well. But first let us see the effect of not using hold on and hold off, not using hold on. So if we do not have hold on, what will happen? If I don't use hold on, this is what will happen. Okay? the last call to the plot function will erase the previous one. So previously we first plotted the cos function f1 and then we plotted the sine function. So but now we only have the sine function here. Why? Because sine function was the last function that we plotted. Okay? So it erased the previous function. If you want to retain that, then you have to use this hold on command. So when you say hold on, you want to say that I want to retain all the functions that I have already plotted. Okay? So if you do it with hold on, then you will be able to see all the functions that you have plotted. Okay? So you'll be able to see all your functions. Okay, so let us create a couple of more functions. We want to demonstrate something else. So let me create, we have cos of 4t, sine of 4t. Let us create a quadratic function and then an exponential function. So let us create these functions. So we have, say, f3 equal to, let us make it as an exponential function. See it? So it is exponential of t. So it is simply e raised to the power, let's make it minus t. Okay? So this would be a declining exponential. Okay? So this is e raised to the power minus t. If you are not sure, so let's see, like exponential of 1, this gives you e, the value of e. Exponential of minus 1, this gives you e raised to the power minus 1. Okay? And then we can have different, what can we say? Different values of t. So we can have a vector t. Okay? Just like here. So we have a vector t. And we are multiplying it with minus. So this is a decreasing exponential. f3 is a decreasing exponential. Let us create a quadratic function, f4. So f4 would be, say, minus, say, minus t square, okay? T square plus 2t and plus or minus 1. Okay? So this is the exponential function, but you have to be careful with the, this is the quadratic function. So quadratic function mein the highest power is 2. So we have minus t square plus 2t minus 1. Now here we are using the exponential function, and we are using the exponential function with a vector, so you have to be careful here. Okay? If you have a scalar value, say for example if you have a equal to 2 and you want to find out a raised to the power 3, this is fine, no problem, it is easy. If you have a vector, say for example this is a vector that we have a, and now we want to find a raised to the power 3, so it will give us an error. Okay? So you have to use the element wise power. It asks you to use the element wise power. Element wise power means you specify a dot before the operator. So this takes element wise power. Okay? It basically does element wise power. So first the power of 1 is calculated, then the power of 2, then the power of 3. You won't get any error. So you will have first 1 cube, then 2 cube, then 3 cube. Okay? So this is what we want to do here. We want to find t square. Okay? So we have to do it element wise. We are using the exponential operator, so we have to do it element wise. If you don't do it element wise, you will have an error like this. Okay? And then this is fine, multiplication is fine. Okay? So we will have f4, we will have the function f4. So we can plot f3 and f4 as well. Okay? So let us plot f3 and f4. So let me plot f3 first, t comma f3, and then we can have the same attributes. Okay, let me copy all these attributes. Okay, line width is fine. Marker, we can choose a different marker. Color, let us choose green for this one. And line style, let us choose this line style. Okay, let us plot the quadratic function as well, f4. We can choose a different marker. I'm not sure like which marker do we have. Let's say this one. And then line style is, let's see if we have another line style, dash 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 and dash dash. Okay, so let's use this one. Let us choose another color. So this would be, let's say cyan. Okay, okay, so let us run this code and see what do we have. Okay, we don't see function number f4. Okay, this is the exponential, the decreasing exponential function, and the rest sine, cosine. We cannot see f4. Let's see why. Let me make the exponential drop a little faster. So, okay, this is minus 2t. Why can't we see this thing? G? Show ho raha hai? Okay, let me back. Acha, we can specify color as red, green, blue values. Okay, so I can specify 0, 0, 0. That means black. I can specify the color as values for red, green and blue. Okay, so we can do that as well. Okay, so let's see. Minus 2t, syntax error. Okay, we cannot say minus 2t, we have to say minus 2 times t. Okay, I still can't see f4. Why? T comma f4, f4, we have f4, minus 1. Let me make it this. Maybe I have selected the wrong marker, so let's select marker. Do we have marker? None. Dot. Okay, so now we can see all 4 functions. Okay, so now we can see all 4 functions. Now you can see the problem here, like if you try to plot multiple functions on the same pair of x's, then you can have issues with scaling. Okay, so some functions would have different range of values that would change the scale of the x's, the x-axis and the y. The x-axis is the same for all of them, but the y-axis is different. Okay, so these functions may not look very nice, okay, the way you want them to be. There is another option, like we can plot these functions separately we can plot these functions separately on a separate pair of axes. Okay? So how can we do that? For that we can use the subplot command. Okay? In order to do that we can use the subplot command. So let me copy this code into another file. So this is Control plus A, C, Control plus V, and let us save it as lab 11 script 2. Okay? Now what are we going to do here? We are going to have all these figures. So right now this is how we have these figures. Okay? All the plots are on the same pair of axes. Okay? Now this can create problems. For example, if I make this exponential a positive exponential, then we'll run into even bigger problems. Okay? So now, like, you cannot, the exponential function is dominating everything. Okay? So you cannot see the cos and sine functions properly because their values are so small and the value of the exponential function is so big. Okay? It is 60, the maximum value, around 60. So the scale has changed so much that you cannot properly see the sine and cosine and other functions. So the other way out for this is, like, you can plot all these functions on a separate pair of axes. How would you do that? So in order to do that, you can use something that we call subplot command. Okay? Now a subplot command creates a grid like this. So if we want all these 4 functions, like I want one function to be plotted here in this corner, the other to be plotted in this corner, the third one in the bottom left corner, and the fourth one in the bottom right corner. So we can use the subplot command for that. Okay? So the subplot command will specify how many squares do you want in this grid. Okay? So it will create a grid, and then you can specify the position for each plot. Then you can specify the position for each plot. So let us do that. Okay? So let me get rid of this hold on. We don't need it for that. Okay? Acha. So we need to specify, we need to create a grid. Okay? And then in that grid we need to specify the position for each plot. So you create a grid and you specify the position for each plot using the subplot command. So here you specify, I want to create a 2 by 2 grid. Okay? And then in that grid, in the first position, which is the top left position, I want this particular function f1. Okay? So here the first 2 arguments, they specify the size of the grid, the number of rows in the grid and the number of columns in the grid. And the third argument, it specifies the position of this particular plot. Okay? Acha. Now we need to specify position for this particular second plot. So again we have to use the subplot command. And we'll say that in the 2 by 2 grid, put this one in the second position. Okay? The second position is this one, the top right position. Okay? So the position, the numbering of the position starts this way, from the top left, and it goes in the right and bottom directions. Okay? So this is the first position, then to the right second position, then we go to the bottom third, then to the right fourth. Okay? This is how the counting goes. So this is the position for this particular plot for F2. For F3, again in the 2 by 2 grid, we want F3 to be at the third position. And similarly, we want F4 to be in the fourth position in that 2 by 2 grid that we have created. Okay? Asha, for the moment I am like commenting of these particular commands, then we'll use them for individual plots, okay? So what are we doing here? Here we are basically plotting all these four functions on the same figure but on different pairs of axes. So each function will have its own pair of axes, its own scale, and you would be able to clearly see how that function looks or behaves. Okay? Now if you run this particular code, this is what we are going to see. Okay? So we have a single figure. This is a single figure, figure 1, and this figure has four different plots, and each plot has its own pair of axes. Each plot has its own x-axis and y-axis. So there are no issues of scale. Okay? Like here the value of the function goes from 0 to 60. Here it swings between -1 to +1. -1 to +1, here -2 to 8. So we don't have those issues of scale. Okay? Now you can specify the title and X label and Y label for all these plots. Okay? We can specify these values individually for all these plots. So the first function is, I guess it is cos t. F1 is cos t. Okay, so this is plot of cos 4t times and then this. Okay, the second function is sin 4t. So let us try to change these values here. Sin 4t. Acha, the third function is the exponential function, I guess. Yes. So the third function is plot of exponential of 2t and the fourth function is the quadratic function. Okay, plot of quadratic function. So we have, say, the function is t squared plus 2t minus 1. T squared plus 2t minus 1. T squared plus 2t minus 1. Okay? Now let us run this code. So now we have the plots of four functions in a single figure, side by side the way we wanted, and all these functions have their own x label. All these functions are plotted on separate pairs of x's, and they have their own x labels, y labels, and if you see here, like this appears like t square plus 2t minus 1. Okay? So we specified it this way. This is how we specified, but it appears at t square plus 2t minus 1. So this is how you can use the subplot command. Okay? Now you can change the structure of this grid. Okay? For example, we can have a 1 by 4 grid, like one row and with 4 columns. Okay? So we can have a 1 by 4 grid. That will not look as nice as this one, but nevertheless, like, we can have it if that is what we need. So we'll have all these figures, all these plots in a single row. ठीक है? So we can have something like this as well. So we have a single row, and in that single row we have all these 4 plots. So you can, if you want to plot more than 4 functions, so you can create a bigger grid. ठीक है? And it is up to you how do you want to organize your plots or functions. ठीक है? It is totally up to you. Okay, so is this clear? Any questions? So you should be able to change or specify the title for a plot, the X label, Y label for a plot. ठीक है? You should be able to change the different properties of a plot or a pair of X's using these different attributes. ठीक है? So you change the values of these attributes using this format, in which you first specify the name of the attribute that you want to change, and then you specify the value for that attribute. So you change these attributes using name value pairs. You specify the name, किस attribute को आप change करना चाहते हैं, और फिर उस attribute के लिए आप value specify करते हैं. ठीक है? This is what you can do in order to make your plot look more friendly or useful, जैसे आप उसको चाहते हैं. Now if you want to have multiple plots on the same figure, उसकी 2 possibilities हैं. एक है कि तमाम जो functions हैं उनको आप एक ही figure में एक ही pair of axes पे plot करें. We looked at that possibility. उसमें problem ये है कि different functions can have different range of values, so then you will have issues of scale. ठीक है? तो बाज़ functions में भी आपको नज़र ही ना आए, या उनका जो करेक्ट बिहेवियर है उसको आप देख ही ना सकें. सो उसके लिए फिर अच्छा तरीका ये है कि यू यूज़ द सबप्लॉट कमांड, और हर फंक्शन को आप एक डिफरेंट पेयर ऑफ एक्सेस पे प्रिंट करें, प्लॉट करें. ठीक है? सो दैट यू कैन डू, एंड वी लर्नड हाउ टू डू दैट. सो यू यूज़ द सबप्लॉट कमांड टू क्रिएट अ ग्रिड ऑफ m by n, एंड देन यू स्पेसिफाई द पोजिशन इन दैट ग्रिड कि उस किस पोजिशन पे कौन सा प्लॉट जाएगा. ठीक है? तो ग्रिड जो आप क्रिएट करते हैं वो कुछ इस किस्म की होती है. दिस इज अ 2 by 2 ग्रिड. ठीक है? सो यू कैन इंक्रीज द साइज ऑफ दिस ग्रिड. इसमें नंबरिंग कहाँ से होती है? नंबरिंग स्टार्ट होती है फ्रॉम द टॉप लेफ्ट कॉर्नर, और फिर वो टूवर्ड्स राइट एंड देन फिर बॉटम की तरफ जाती है. ठीक है? सो 1 इज द टॉप लेफ्ट एंट्री, देन टॉप राइट 2, फिर बॉटम लेफ्ट 3, बॉटम राइट 4. अगर इसमें ग्रिड में और भी आपके पास सेल्स हैं तो फिर उनकी नंबरिंग मुख्तलिफ तरीके से होगी. फॉर एग्जाम्पल इफ़ यू क्रिएट 4 by 4 ग्रिड. ठीक है? से फॉर एग्जाम्पल वी हैव 4 by 4 ग्रिड, तो उसमें फिर नंबरिंग कैसे होगी? सो उसमें दिस वुड बी, लेट मी इंक्रीज द फॉन्ट साइज इनका. Okay, so this would be position number 1, this would be number 2, number 3, number 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. ठीक है? So this is how P would change. So m by n में this is m भी 4 है, n भी 4 है, दोनों की वैल्यूज 4 हैं. वी हैव 4 rows 4 columns in this grid. So p की वैल्यू जो है, आप 16 फंक्शंस को प्लॉट करना चाहते हैं साइड बाय साइड इन अ सिंगल फिगर. सो p की वैल्यू यूं वेरी करेगी. 1 जो है वो ये पोजीशन होगी, 2, 3, 4, 5, 6, 7, 8, 9. ठीक है? अच्छा, नाउ व्हाट डू यू नीड टू डू? सो यहाँ पे आपने, आई होप लाइक यू हैव बीन फॉलोइंग मी, और ये काम आपने किया है. सो व्हाट यू नीड टू डू इज you need to select 6 functions of your choice. ठीक है, 6 functions of your choice, और पहले उनको एक 2 by 3 ग्रिड में प्लॉट करें, ठीक है, एंड देन प्लॉट दीज फंक्शंस in a 3x2 grid. ठीक है, तो 6 फंक्शंस सेलेक्ट करें अपनी मर्जी के. दोज फंक्शंस शुड बी डिफरेंट देन दीज फंक्शंस एंड द फंक्शंस दैट आई चोज. ठीक है, और फिर उन फंक्शंस को प्लॉट करें इन अ ग्रिड ऑफ 3x2 एंड 2x3. ठीक है, और प्रॉपरली लेबल करें एक्स एक्सिस को, वाई एक्सिस को, और टाइटल दें हर एक प्लॉट को.